All right, on today's episode of Python Papi, we're back inside our smart contracts journey. Let's have a look at what we went over today on day one. Now, today was a heavy note taking day. As you can see, we did take a lot of notes. Did get a lot of basics down. Let me see if I can pan over the whole page for you. This is everything from today. Just some concepts that we need to understand and get a grasp of as we move forward and diving into the basics and getting the foundations under our belt as we move into this project. So you can see this first module we're going to be in is called Blockchain Basics. And basically, it's going to be this is where we start our blockchain basics, smart contracts, or a set of instructions executed in a decentralized way without the need for a centralized or third-party intermediary. Remove centralized forces and counterparty risk. Now, this is one of the main differences between Bitcoin and Ethereum. Technically, Bitcoin does have smart contracts, but it is intentionally a turn-in incomplete. This is done by Bitcoin developers purposely who viewed Bitcoin as a store of value. Now, Ethereum developers view Ethereum both as a store of value and a utility to facilitate these decentralized agreements. Now, Bitcoins are intentionally walled off. This is what's known as the Oracle problem. Now, Bitcoin is a deterministic system, and it is a deterministic system on purpose. Everything that happens with them, everything that happens with inside the Bitcoin ecosystem stays inside the ecosystem. That's why it's called walled off. So it doesn't really get any influences from the outside world. Now, what is an oracle? An oracle is a third-party data source that provides information to smart contracts. So since Bitcoin is an oracle or a walled-off platform, it's hard to get third-party information to make the platform run more efficiently. So there are things that are implemented to make sure Bitcoin can access third-party information that'll make the platform run more efficiently, more data-driven. Now, see here, however, if we want our application to stay truly decentralized, we can't work with a single oracle. So we need a decentralized oracle network similar to a decentralized blockchain network. Our on-chain logic will be decentralized, but we also need our off-chain data to be decentralized. Now, combining the two gives us a known phrase called the hybrid smart contract, which is the on-chain plus the off-chain agreement. Now, most of the biggest protocols in DeFi are hybrid smart contracts or interact with hybrid smart contracts. And this is where the protocol Chainlink comes into play. It is a modular decentralized Oracle network that provides off-chain data to on-chain smart contracts. So the chain link is something that we can use to actually get around the Oracle problem that we see within the Bitcoin ecosystem. Because it is walled off, we can use a chain link system that provides the off-chain information to our on-chain information. And this is where we can actually provide our Bitcoin or other closed-off ecosystems with the information they need from the third world sources that help us actually use the data we need to make sure our platform runs more efficiently. Now, those are just some of the topics that we touched on today. Like I said, we took a lot of notes and we touched on a bunch of topics. I'm not going to read over all of them, of course, but just letting you know this is where we are. We haven't started any coding yet. I have a feeling that we're going to do a lot of note taking in the beginning days, just getting a grasp of everything that's going on within the smart contracts ecosystem and making sure we have a strong foundation before we move on to actually writing any code at all. But of course, I will keep you posted every step of the way. That was just some light reading. We'll probably do light reading from here on out until we start coding. But I will keep you posted every step of the way. For now, this is the Python Papi. You guys stay Gucci.